These are NCERT numericals of motion in straight line. Let us see this one. This is position time graph for two children A and B returning from their school O. So O is representing school. O is school and the graph is position time graph. This is position and this is time. They are just going to their homes P and Q respectively. So P is home of A. P is home of A and Q is home of P. Home of B. So first part is who lives closer to school. So O is school. So who is closer? P is closer. That is home of A is closer. So A lives closer to school than B. A lives closer to school than B. So this is first part. Getting to the second part. Dash starts from school earlier. So you can see A is starting earlier and B is starting at this time. B is starting late. So A is starting earlier than B. Who walks faster? So for that we will check slope of the graph, position time graph. Whose angle is more? Angle of B is more. So that means slope of xt graph is more for B than slope of position time graph for A. So slope of B is greater than slope of A, that is speed of B is greater than speed of A. So who walks faster? B walks faster than A. Getting to the next, who reaches home? Do they reach home same or different time? So you can see here B is reaching at this time, B is reaching at this time and A is reaching at this time. So A is reaching late. According to this graph right now they are arriving at different times. Now who overtakes whom on road once or twice? So you can see B is overtaking A here and then going ahead. So you can see intersection has taken place once. So here it is once. And who is overtaking? Because B was walking faster, so B overtook A. So B overtakes A on the road and once. Let us see the next question. A woman starts for her home at 9 a.m., walks with a speed of 5 km per hour up to her office, which is 2.5 km away. So home to office. So what is the distance? .5 kilometer. And speed of the woman is 5 km per hour. Now she stays up to office, in the office up to 5 p.m. and returns home with a speed of, this is 25 km per hour. Okay, so now it is office to home. Office to home. distance is same 2.5 kilometer, but this time her speed is 25 kilometer per hour. So using formula of time is equal to speed upon distance. No, distance upon speed, sorry. Distance upon speed. Time is equal to distance upon speed. So we can put the values. Distance is 2.5 kilometer and speed is 5 kilometer per hour. So kilometer cancelled. Similarly here we have 2.5 kilometer and this is 25 kilometer per hour. Kilometer cancelled, and here 2.5 and 5 will give you half hour, that is 30 minutes. She takes only 30 minutes to reach office, home to office, and here it will come 1/10 hour, which is 6 minutes. So when she goes to home from office, she takes 6 minutes. Now actually we have to plot xt graph, position time graph. So when we're drawing that, so this is position, this is time, this is her home, H is home, and she starts her journey at 9 a.m. So you'll write here 9 a.m. Okay. So now she takes 30 minutes. So it's 9:30, and at 9:30 she reaches her office, which is 2.5 kilometer away. So all the details to be shown, and you have to draw a straight line till here. It should be straight. So she reaches office at 9:30. This is 9:30. Now she stays in the office up to 5 p.m. So she stays up to 5 p.m. and then within 6 minutes. So here is only 6 minutes. She reaches home. Okay, so this graph is gradual. When she is going, she is taking 30 minutes. She stays in office and then she reaches quickly. So it has to be steep. Okay, so this is the kind of graph that we obtained for position and time with all the details. Now the next question. A drunkard walking in a narrow lane takes 5 steps forward, 3 steps backward, followed again by 5 steps forward, 3 steps backward, and so on. Each step is 1 meter long. So one step is 1 meter. And how much time does it require? Time for one step is 1 second, given in the question. We have to plot distance time graph, xt graph, and determine graphically and otherwise how long the drunkard takes to fall in a pit 13 meter away from the start. So we will we'll have to draw a position time graph. So let us take one position and one time coordinates we will take. So let us substitute. It starts with 0 0 obviously. Position it as 0 and time is also at 0 in the beginning. So we can draw the graph. So this is position and this is time. Position, time, 0 0. So first reading is this. 0 0 is origin. Okay, now he takes 5 steps forward and one step takes 1 second, so 5 seconds. So next reading is 5 5. So you can see you can divide it equally using scale. Suppose it is 1 2 3 4 5. So this is 5 for me, and 1 2 3 4 5. This is 5. 5 on position, 5 on this. So this is my first point, matlab second point. First is 0 0. Now coming, then it takes 3 steps back. So it means 5 minus 3, position will be reduced by 3. So it will be 2, but time will be added. Time will not be reduced, na? So this will be 8. Now we have to plot 2 8. So 2 on x, 2 on x, and 8 on time. So 2 on x will be here. You can see this is 1, this is 2, and 6, 7, 8. This will be the point. Or you can make it little farther so your graph will be different. Now getting to next, then it takes 5 steps forward. So steps will be 7. So time will also always be added. So 7 and 13. X on 7. So this is 6, this is 7. And it was 8, 9, 10, 11, 12, 13. Okay, so this is a point now. Then 3 steps backward, that is 4, 7 minus 3. And but time will be added. So it is 16. So you can plot this too. 4 on this is 4 on x, and 14, 15, 16. So this is the graph. This is a point. Then 5 steps forward. So plus 5, 9. Time will always be added. So 9 and 21. So you can see this was 7, 8 and 9. This is 9 for x, and time is, this was 16 time, 17, 18, 19, 20, 21. So this is a point. Okay, now 3 steps back. So minus 3, 6, but time will be added, 24. So similarly you can plot 6 and 24. Okay, then 5 forward. So 11 and 5 to this, yani ki 29. Then minus 3 backward, 3 steps backward. So 8, and this will be your 32. Now 5 steps forward. So 13, and this is plus 5, 37. Now 13 meter away there was a pit, he fell into the pit. That's all. So we have to reach up to this. So you can plot all the points. Okay? These 2 points I have not plotted. So you can plot these 2 points. and you can make them join with free hand. That is a kind of the graph. So in how many minutes will he, in how much time will he fall into the pit? 37 seconds. In 37 seconds, and this is a solution graphically. So graphical solution we have discussed. Okay. Now alternative solution. They have asked for alternative solution also. So you can see the drunkard is taking 5 steps forward and 3 steps backward. Sorry, 3 steps backward. So in time wise he is taking 8 seconds. Time will be added always. So 2 meters he cover basically in 8 seconds. In 8 seconds he covers 2 meters. Now multiply both the sides by 4. So basically he will cover 8 meters in 32 seconds. Now 5 steps forward and 5 seconds added. So in 37 seconds he will fall into the pit which is 13 meters away. So both methods we have discussed. This is alternative method. Okay, alternative logical method, and that was graphical method. So getting to the next question. So let us see this question. A jet airplane traveling at a speed of 500 km per hour. So this is speed of jet plane 500 km per hour. It ejects its products of combustion at the speed of 1500 km per hour relative to jet plane. So this is speed of V for speed of products with respect to jet plane. So it has to be written this way, and it is equal to 1500. Now as we all know that plane will go this side, so products will be ejected opposite to that. Okay, so products means gases, etc. Gases, smoke. So the direction is opposite. So we'll put here negative sign. So what is this? This is V for speed of products with respect to jet plane. This can be written as speed of product minus speed of jet plane is equal to minus 1500. Now we can substitute this. So speed of product can be obtained. This 500 will go on that side. Will go into addition, and then velocity of products will be found as 1000 km per hour. Let us see this question. A car moving along a straight highway with a speed of this. So this is initial velocity 126 km per hour. It is brought to stop. It means final velocity is 0. Within a distance of, so distance is 200 meter. What is the retardation of car and how long does it take for the car to stop? So we'll convert 126 km per hour into meter per second. How to convert into meter per second? We'll multiply with 5 by 18. Okay, so it will come as 18 7 the 7 5 the 35 meter per second, and final velocity is 0 meter per second because it has to stop. Now we have to find out retardation and time. So we will use the suitable equation u, v, s and a. So which equation should we use? Third, v square minus u square is equal to 2as. V is there, u is there, s is there. You can substitute and you can find out a. Similarly, now select an equation in which t comes. U, now a is already there with you. A will come as something around minus 49.16. You solve and obtain. So u, a, t, s you can use to find out t. That is second equation of motion you can use. Second equation of motion is ut plus half at square. S is there, u is there, t is to be found, and t is to be found. This will be a quadratic, or you can use simply either you can use this formula, or simply you can use acceleration is equal to v minus u by t. Okay, that will be easy. Acceleration is minus 49 by 16. Now v is given, u is given, t can be found easily, and t should come as 80 by 7 seconds. Kindly confirm your answers after solving. Now in the next question, two trains A and B, each of length 400 meter, are moving on two parallel tracks with a uniform speed of 72 km per hour in same direction. It means speed of A is also 72 km per hour and speed of B is also same 72 km per hour, and A is ahead of B. Train A is ahead of train B. The driver of B decides to overtake A. Train B is behind train A. Okay, B's driver decides to overtake A, so he accelerates. B decides to accelerate with 1 meter per second square. So acceleration is 1 meter per second square. After 50 seconds, he overtakes. So time is 50 seconds. Now we'll have to find out what was the original distance between them. What was the original distance between the trains? So we'll have to find out S. Now A is there with us, T is there with us, S we have to find. We only need U. U means how much extra velocity B has with respect to A. So there is no extra velocity, both are having same velocity. Basically relative velocity of B with respect to A. Relative velocity of B with respect to A, which is how much extra velocity B had with respect to A. So it's 0. So this will act as 0. Okay, 0 km per hour or 0 meter per second. So now we'll use U as 0, A as this, T as this, S is to be found. So using second equation of motion, S is equal to ut plus half at square. Let us substitute. 0t is 0, half A t square is 50 into 50, so it will come as 1250. Okay, and so this is the distance, but if you wish you can subtract the length of both the trains. Okay, length of both the trains, if you wish to report that way. So length of each train was given as 400, so 800 you can subtract from 1250. Take it to 450. Otherwise this is also okay, but if you wish you can report up to 450 meters. On a 2-lane road, car A is traveling with a speed of 36 km per hour. The speed of car A is 36 km per hour. So car A is moving with a speed of 36 km per hour. B and C are approaching car A from opposite directions with a speed of this. So B is approaching and C is approaching it with a speed of 54 km per hour. So you can see I have written 54 km per hour, but because C is approaching it from opposite direction, so it will be negative. This is approaching it from the same direction, so it is same sign. So just keep in mind about the sign of the quantities. If direction is opposite, that has to be mentioned with sign. So this is one rule. Now at a certain instant, when distance AB is equal to AC, distance AB, distance between A and B is equal to AC at some instant when it is equal, and it is equal to 1 kilometer. So distance between A and B is 1 kilometer, and distance between A and C is 1 kilometer. B decides to overtake A before C. B is deciding, right? So what minimum acceleration B is required to have to avoid an accident? Okay, so B is deciding to overtake, so we will begin with C, right? So what is the distance between A and C? 1 kilometer, that is 1000 meter. Then what is the advantage of speed that C has? यानी कि relative speed of C with respect to A. What is the relative speed of C with respect to A? So you can see it will be velocity of C minus velocity of A with sign. Velocity of C is this minus 54 minus 54 minus, and VA is written as 36. So relative velocity, that is how much advantage C has over A. So we can see this will come as 90 km per hour. If we wish, we can convert into meter per second by multiplying with 5 by 18. So 18 5s are. So relative speed of C with respect to A, how much advantage car C had over car A in terms of speed. So minus 25 meter per second. So this will act as U. So U you have, S you have, ठीक है, acceleration will be 0 because C is not accelerating. B has decided, so B has to accelerate. ठीक है, तो C का acceleration is 0. So now we can use, we have U, how much advantage C has, distance S, and A, so we can find out T using second equation. S is equal to ut plus half at square. So it is a into t square will be 0. U into t would be your minus 25 into t, and this is 1000 is equal to 25 into t. Okay, time cannot be negative, so there is no point. So time is coming as 40 seconds. Okay, and this is the time that we have calculated using C. C has not decided to overtake. B has decided, but you find out that without changing any speed, है ना, whatever it was traveling with, how much time will it take? So it will take 40 seconds. So this time we will use now for B. Time we obtain for 40 seconds. Distance is 1 kilometer, that is 1000 meter. Now, how much advantage B had over A? That is relative speed of B with respect to car A. Formula is speed of B minus speed of A with sign. So you can see B ka speed is 54 and A was 36. 54 minus 36, 18, but it is in kilometer per hour. It is in kilometer per hour. So we'll convert this into meter per second. So 18 into 18 is cancelled and kilometer per hour will change into, so it is 5 meter per second. So this is the advantage that B had. So this is initial velocity of B, matlab with respect to A. So this is U. U we have, S we have, T we have, so we can find out A, which is a question. Find out the acceleration B. So let us use second equation of motion. S is equal to ut plus half at square. Now S is 1000 meter, U is 5, T is 40, and this is half. Acceleration is to be found. This is 40 into 40,000. This is 40 into 5 is 200. 200 will come this side. So it is half A, and this is 1600. So this is 800 is equal to half A into 1600. But the half and 1600 will give you 1800. Sorry, 800. So 800 cancel is 1 meter per second square. So this much acceleration B has to give to overtake A before C does. Getting to the next question. Let us see this question. Two towns A and B are connected by a regular bus service. So bus leaving in either direction every t minutes. A man cycling with a speed of 20 km per hour in the direction A to B. So from A to B. Okay, let us consider speed of bus VB. मैन का स्पीड हो गया VM. Man is cycling with the speed of this. Notices that a bus goes past him every 18 minutes in the direction of his motion. So man is going from A to B. and bus is also going from A to B, he observes that after every 18 minutes. So case 1 for A to B. So let us find out relative speed of bus with respect to man. With respect to man. So it is V B bus, B for bus, with respect to man, and this is equal to V bus minus V man. V bus and minus V man is 20 km per hour. It's written here. So, and what is the time that he observes? After every 18 minutes. So 18 minutes, that means 18 by 60 hours. So what is the distance? Distance between AB. Distance is speed into time. Distance is speed into time. So what is the speed? VB, V bus minus 20, V man, this is V man, into time is 18 by 60. 60. So this is one equation for distance between town A and town B. Now let us read. And every 6 minutes in opposite direction. Okay. Now again town A and town B, and man is cycling from A to B. Man is cycling. Okay, but you observe that the bus is coming from opposite direction after every 6 minutes. Yeah. After every 6 minutes, the bus is coming from B to A. Bus is coming from B to A after every 6 minutes. That man observes. The man on cycle. So, case number 2. B to A. Okay, now when bus comes from B to A. So, again we will find out relative speed of bus with respect to man. So velocity bus minus velocity man. Velocity bus is velocity bus, and this time man's velocity is to be taken minus 20, because bus this time is coming from B to A and man is going from A to B. Okay, so this time it has to be put with negative sign because its direction is opposite to the bus. So this is very important. VB plus 20, and time is how much that he observes after every 6 minutes. And what is the meaning of 6 minutes? 6 by 60 hours. So we can again find out distance AB, distance between town and town B, distance, speed into time. So speed is how much? V bus plus 20, and time is 6 by 60. This is equation number 2. Put both the equations equal. So equation number 1. Why? Because both are equal to AB. Okay, so AB from equation 1 is equal to AB from equation 2. So what is AB from equation 1? That is equal to V bus minus 20, and it was 18 minutes I think. So it was 18 by 60, and this is V bus plus 20 and 6 by 60. So you can see 60 cancel. 6 3 by 18. So V bus minus 20 into 3 is equal to V bus plus 20. Okay, open the bracket. So 3V bus minus 60 is equal to V bus plus 20. Now V bus will go this side. So 3VB minus VB will be 2VB. And 60 would go this side, so it is 80. So what is the velocity of the bus which is flying from A to B and B to A? 40. So this is one thing that they have asked, right? And now you can put this in one equation and we can find out the time taken. For example, first equation I am writing using equation number 1. Equation number 1 is AB distance is equal to V minus 20 into 18 by 60. Now V is 40. So 40 minus 20 into 18 by 60. Now I'll be writing this also, this distance also, speed into time. Normal speed and normal time. Okay? So it's 20 into 18 by 60. It's 23 36. And here we will put 40. It's kilometer per hour. Okay, so we'll keep this in mind that this is in kilometer per hour. Sorry, it's not kilometer per hour. We have taken on our own. So it's meter per second, sorry. No, it was kilometer per hour because we divided by 60, yeah. We converted this into hours. So it is 20, 40 and this is T. So now this came as T equals 6 by 40. T is equal to 6 by 40 hours. Now T is equal to 6 by 40 into 60 minutes. So 2 3s are 6, 2 2s are 4, 2 3s are 6. So the time is this. So this is the time from A to B, B to A for the bus time period. Okay, and velocity we have already reported. It was in kilometer per hour. There is no confusion. We converted. When it was given 6 minutes, we converted into hours. So yes, let us see the next numerical. Question number next. A player throws a ball upwards with an initial speed of this. So initial speed of the ball is 29.4 meter per second. What is the direction of acceleration? So ball is going up. Okay. Part A. What is the direction of acceleration during upward motion? So there is only one acceleration which is acting on the ball, and that is acceleration due to gravity. Gravity is pulling it down. The direction of acceleration is downward. You'll have to write the complete sentence. There is only one acceleration which is acting on the ball, which is acceleration due to gravity, due to Earth's gravity, and that is downwards. Coming to second part, what are the velocity and acceleration at highest point? So you know when ball is thrown up, ball will reach the highest point and it will stop there. So velocity is 0. At highest point velocity is 0, ball will stop, but acceleration will be downward only because there is only one acceleration which is involved. So acceleration is acceleration due to gravity, which is 9.8 meter per second square or 10 meter per second square, and it is acting downward. So downward. Now x is equal to 0, t is equal to 0. They are saying choose, and the time of ball at its highest point, vertically downward direction to be positive. Okay, so they are saying take downward direction to be positive. Give the signs of position velocity, acceleration of the ball during upward and downward motion. So when the ball is going up and when ball is coming down, we have to tell the signs for these things. See, position will always be positive, it is a scalar quantity. Because the position will be positive in going up case and going down case. Position is positive. Position is positive. Velocity when you are going up, so you are going up, so downward direction is positive according to the given statement. So velocity is negative because you are going opposite to downward, and when coming down, velocity is positive because positive direction is downward according to them. And acceleration all the time, whether the ball is going up or down, acceleration is only acting downward. So acceleration is positive when the ball is going up and acceleration is positive when the ball is going down. Now let us see the last part. To what height does the ball rise? Height is to be calculated, that is distance. Taken, and how long does it take to return? G they have given as 9.8 meter per second square, that is acceleration. Okay, and the ball was thrown with velocity of 29 meter per second. 29.4 meter per second. So see, the ball was thrown up. Okay, the ball was thrown up, so velocity will be negative because downward direction they have considered positive. Acceleration x downward, so I have taken this positive. Ball is going up, so I am taking this negative. Okay, and at highest point, final velocity will be 0. Velocity at highest point is 0. It stops for a moment. When we throw things up, final velocity is considered 0. Now u, v, a, s, you can use third equation. V square minus u square is equal to 2as. V square is 0 square. U square is minus 29.4 and 29.4. Negative का square will be positive. Okay, so this negative will be as it is 2. Acceleration is 9.8. S can be calculated, which is height. So calculate and report. Then we have to calculate time also. So for that, you can use VUAT, first equation. Using first equation of motion, V is 0, U is minus 29 because it was going up direction is negative, and acceleration is 9.8, and time is to be calculated. Now 29.4 will go that side positive, and 9.8 will come into division. Okay, so it will come around 3. This is time is 3 seconds, but this is the time to reach maximum height. At highest point velocity is 0. So this is the time to reach maximum height. The ball is going up, reaching the maximum height. Now it will come back. So the total time would be 3 plus 3, that is 6 seconds. This is the time to reach maximum height. Now it will come back also from maximum height. So it will be double of that. Total time will be double of this. Let us see the next question. Let us see this question. We'll have to find out true or false. An object with 0 speed and 0 acceleration. That is okay. If speed is 0, so acceleration can be non-zero. And this is we have seen at highest point. At highest point the body stops and then it falls down. So when the body is at highest point, speed is 0. Okay, but acceleration is not 0. Acceleration is how much? 9.8 meter per second square. So you have to remember the example also for this. This is important. Zero speed and non-zero velocity. No, this is not possible. So this is false. If speed is 0, not moving, then not moving. Yeah, but vice versa can be true. Zero velocity can be there, but non-zero speed, that can be true. Zero velocity and non-zero speed can be true. Constant speed must have zero acceleration, that's true. If speed is single, there is no acceleration. This is true. When speed is single, one speed, so nobody is accelerated. With positive values of acceleration must speed up. So acceleration is increase of velocity, rate of increase of velocity. Okay. So if you are giving acceleration, does it mean that body is speeding up? So no, not possible. Matlab not really. If the body's initial velocity is opposite direction, so initial velocity is already negative. In that case, if you are speeding, so it will become more negative, that is less. Okay. So this is false. This is true. Then false and first is true. A ball is dropped from a height of 90 meters on a floor. At each collision with the ball loses 1/10 of its speed. Plot the speed time graph of its motion between 0 to 12 seconds. So when ball is dropped, it means initial velocity is 0. When ball is thrown up, then final velocity is 0, right? Now it is dropped down. So initial velocity is 0. Height is given 90. Okay, acceleration, acceleration due to gravity will be involved and we can take it for convenience. 10 meter per second square or 9.8. You can take either. Now let us see, we'll have to plot speed time graph. So find out speed when it is about to hit the ground. What is the speed? So we'll use UHAV, that is third equation of motion. V square minus, or you can use, you can use your third equation of motion. 2AS, so it is V square, U square is 0, 2 into A into S. Okay, the V you can find out by taking the square root. So 10 out, 9 ka 3, and it's root 2 everyone knows. It's 1.414. So you can see it will come up approximately 42. So approximately 42 when it is about to hit the ground, the ball. Okay, and time kitna laga? Time also we can find out using first equation, U plus 80. U plus 80. So V is 42, U is 0, acceleration is 10 and time is, we don't know. So 42 divided by 10 is equal to 9. So time is coming as 4.2 or so 4.2 seconds. Now we will note these things down, that this is when it falls down. Before hitting the ground, its velocity was this much. First fall ke dauran, and time taken was this much. This is first reading. Now the ball will jump back, rebounds. So we will talk about now those things. We have to collect so many velocity and time so that we can plot a graph. So this is one velocity. The initial velocity was 0. Now this is the velocity on hitting the ground, and this is the time taken. So this is one reading. Okay, now coming to, it loses 1/10 of its velocity according to the detail. ठीक है, तो भैया velocity when it is about to touch the ground was 42 meter per second. 10% lost, it means 4.2 lost. So how much is the velocity with which ball is rebounding? This much is the loss, so you can subtract 42 minus 4.2. This is the initial velocity of rebounds. It is 37.8. So this is the initial velocity with which ball is rebounding, and rebounding means it is going up, and in going up we know final velocity is 0. So this is u, this is v, acceleration is same, but because the ball is going up and acceleration is coming, acting downward, so we'll take it negative 10, because the ball is going up and acceleration is acting downward. So u, v, a we have, and this is important for us because we need this for plotting. And then acceleration, we can find out time. V is equal to u plus at. Let us substitute. V is 37.8. Sorry, this is V is 0. This is 37.8. Acceleration is 10 and into t. So it's minus 10. So minus 37.8 is equal to minus 10t, minus cancelled, and it will come as 3.7. Okay, we will take it as 3.8 or 3.9, 3.8. So this is the time. This is important for me. Time and velocities are important. Okay, so earlier how much time was consumed? 4.3, 4.2. Okay, time 1 was 4.2, time 2 is 3.8. So now ball has gone up and it is here, final velocity 0. Now it will come down. Take it to hit the ground again. So it means now it is coming down, so u will be 0. Acceleration coming down, so acceleration will be positive because acceleration acts down. And see, we should find out the time taken to go up was 3.8. So the time taken to come down will also be 3.8. Time taken to come down will also be 3.8. So we can find out final velocity when it is about to hit the ground. So u plus at. So u is 0 and at would be 38 meter per second. Okay, this is your velocity upon hitting the ground. And what is this? Is third time. So let us analyze at all the readings, everyone. What do we need? We need a velocity time graph. So we can take. Let us write down all the events that has taken place. First of all, we dropped from a height of 90 meter on a floor. ठीक है? तो first time we have dropped. ये 90 meter था. Dropping means u is 0. So 1 u we need. Then before hitting the ground, we found one velocity. You can write down that velocity v1. ठीक है? Then it went up. This is second event. ठीक है, let us note down all the event, all the details so that we can plot. And time 1. So I remember, you can scroll up and see. देखो, first velocity was, before hitting the ground was 42 and time was 4.2. So note it down. Let us come this side and note down. First velocity was 42 and time is 4.2. Now ball is here, so it will go up. When it goes up, one velocity is 0. ठीक है, and that is final velocity. So this is v4, v3, and v2 here is after 10% loss in this. We have noted that also down. That is 38.4 meter per second. I don't know, but yes, 38, approximately 38. Let us see this value. Yes, it is 37.8, so it is okay, 38. And time came as 3.8. 38 and 3.8. So we have time 2 as 3.8. Now this was the velocity, this is time to go up. Okay, now when it will fall, so velocity is 0, and time to for fall will be again same as time of going up. So 3.8, this is my third time, and my velocity I found before touching the ground was, I calculated it and it was approximately this 38. So I should be ready with all the values. Now let us plot. Important question as in concept wise. So see, it started with 0. So this is my velocity and this is my time. So it started with 0. Initial velocity was 0 because you are throwing down. ठीक है, तो ये रहा तुम्हारा initial velocity 0. Now you have to reach up to 42. So let it be 42 meter per second. And time is 4.2. So let it be 4.2. So you have to reach up to here with a straight line. So this is coming down. Okay. Now 10% is lost and you got up to this velocity. To rebounds, on rebouncing 10% are getting lost. So let it be 38.4. So it reduces to 38.4 and you took 3.8 seconds to make velocity 0. Velocity 0 is here. And if you will add 3.8 more, it will come as 8. So ये 8 second है यहाँ पे. Again velocity becomes 0 here, again a straight line. But you look here, there is a fall. 10% fall you have to show. This is 10% fall. Now final velocity is 3.8, so you have to reach up to 3.8 again. This is 38.4, so you have to reach up to 38. So 38 is very near, and in next this much second, so add 3.8, so that is approximately 12, or you can say 11.8. 8 में ये add करेंगे तो approximately 12 you can say, so let it be 12. और we have to draw up to 12. तो ठीक है, तो here it should reach up to 38 meter per second. So this kind of graph will come. This is for dropping, then rebouncing, going up, coming down, first graph, going up, second graph, and coming down, the next graph. So this is an important question, do it.